Okay, right now I would like to start with our first demonstration file. And with that demonstration file, you'll need to go to Blackboard. And on Blackboard, you will need to scroll down to the quizzes and in-class work. And then in that folder, you're going to find a folder called Excel Demo Files. And with those Excel Demo Files, you're going to click on the Chapter 10 Excel Demo file and download the Excel Workbook Starting File Demo. And this same link here, the Chapter 10 Excel Demo file, will be where once we complete all 4 sheets of this Excel spreadsheet, we will upload this back up and submit it by Sunday, July 1st at 11 p.m. for points on your in-class work grade. So let's go ahead and open up that file. Enable editing on that. So you're going to notice here at the very bottom, we have 4 different sheets within our Excel workbook. Our first one is address and function starter. Our second sheet is conditional starter. Then we have a VLOOKUP starter, which really looks no different than our conditional starter, because we're going to work through the same exact example. And then lastly, we have a VLOOKUP starter 2 that we will finish out. So I will do each one of these sheets in a separate video for you. But let's hop back to our address and function starter sheet. One of the key features with Excel is that you always want to make sure that you know what day that you worked on your Excel spreadsheet, make sure that you know who the author is of your Excel spreadsheet. So we have some required information that we're going to put at the top of every Excel spreadsheet that we work in. And so here in cell A1, so this is my cell that I'm going to start typing in, I'm going to put my name so I know who's been working on this. And then in cell C1, so I'm just going to skip over a blank cell. And in cell C1, I'm going to indicate what this spreadsheet is kind of for. And then in cell E1, I'm going to actually put in the date that I am working on this. And so I'm recording today on 6/18/2018. So I'm going to enter my date in there. And then on row 2, we always want to let the user know exactly what our spreadsheets are used for. So here, I'm going to actually put in a problem statement. So this problem statement is much like your problem definition in our problem-solving process, but this kind of just gives the user of the Excel spreadsheet or anyone who's working in here at a job or such, they're going to know exactly what the spreadsheet is used for. And so in this class sheet, I'm going to actually put my problem statement here in this first sheet as introducing you so that introduction to cell addressing and basic Excel functions, including, and we're going to start using some conditional formatting in our statement. And so I'm actually going to turn this italicized so that it looks a little bit different than our first row here in our Excel spreadsheet, which I am going to make bold since it's kind of like our header on the Excel spreadsheet. I'm going to zoom in here so that this is nice and large. So I just zoomed in by going down to our bottom right-hand corner over here, and there's kind of a plus to minus scale. And you can either click on the percentage and customize how far you want to zoom in or add your plus or minus to make sure that things fit on the screen. So I'm going to come up here, and in this, in our introduction to cell addressing, we've got some different colored cells up here. And so we notice that we've got this deep orange with white bold lettering for our volume. And we have volume V in CC, our cubic centimeters is what CC stands for in our units for our volume. And then just below volume, we have, again, a second header for length, L, in centimeters. And so based on this information, we are just going to assume if we input a volume of 9, and so and hit enter, our 9 is going to show up in our cell. This cell here is a light orange because this is a user input cell. So we use shading on cells to indicate different things for our user. Usually a lightly shaded cell is a user input, meaning that we want them to input something or select something from a list. And then a blank cell or with no color formatting is going to be something that is going to usually be a calculation cell or something that includes a formula of some kind. So basically we have a volume in 9 cubic centimeters, and we want to find the length. We can use a function to do this based on the fact that a volume to length means that we are taking the cube root of something, meaning we've got a cube that contains a volume of 9 centimeters cubed. We want to find the length of the side of that cube here. And so I can do this 2 different ways. I'm going to start my formula with my equal sign, and then I'm going to reference back to the cell above, which is B5, and I'm going to take this cube root of this, so that I'm essentially saying I want to take this to the 1/3 or cube root. If I wanted to cube it, then I would just put a 3 there. And so I know that each side of my cube is going to be 2.08 centimeters if I have a volume of 9 cubic centimeters. So if I make this 21 in my user input in B5, you're going to notice that my side length now updates accordingly based on what the user inputs for the value of the volume. So I can put 8 here, and I'm going to get 2, or I can do 49, and I'm going to get 3.659. And so we have a lot of decimal places in this B6 cell. And so we can change the number of decimal places a couple of different ways on a cell when we format it. So here, I right-clicked in my cell, and I'm going to go down to Format Cell. It's going to pop up a little window. And so it tells me that I've got a number. Right now it's just in a general format. So I can change that to a number format and indicate the number of decimal places. So I can either go to a single decimal place by clicking on the up and down arrows. We're going to use 2, which is the default setting here for our number. And just for right now, I'm going to click over in cell C6. I'm going to show you the other way that we could have done a cube root. Instead of using that caret symbol in our formula here, this caret symbol here, which is Shift 6 on your keyboard, we are actually going to use another built-in function. So I'm going to start my formula with my equal sign, and I'm going to use the power function. You're going to notice up here, just below my function bar, that I'm getting a little hint from Excel about the syntax of my power function. And so it's saying, once I put my parenthesis there to indicate I'm now inputting or using my function, it's kind of giving me a syntax of what it thinks I'm trying to do. So it's telling me to input the number. And in this case, my number is located in cell B5, so I can either type B5 or I can click on B5. So when I left click on B5, it kind of puts this blue box around it, and it puts the cell reference of B5 up here. And then I put my comma, and it asks me what power I want this to. So in this case, we want it to the power of 1 divided by 3, or that cube root. I end out my parentheses and hit enter, and I should end up with the same exact number as I have in B5 or B6. Again, I would want my decimal places to be reduced. So another way that you can reduce them is go up to the bar at the top, and if you don't have yours pinned, you may sometimes have to bring it down. So if you click on Home, and there's a little like push pin icon, so we're going to pin that ribbon to the top so that we can quickly page through our different pages here in Excel and get to the different functions. But up here under General, we can either change this to a different format for our cell, or we have this little arrow 0 to 00 where we increase the number of decimal places or decrease the number of decimal places. In this case, I'm going to decrease it down to 3 decimal places, just so it's a little bit different. So again, if I go back to cell B5 and I enter 8, it should automatically update in both cell B6 and C6 according to the different functions that I have put in here. The other thing I'm going to do is I'm actually going to center my text in my spreadsheet. So we always like things to look very standard and formatted. One of the ways that we can do this is to center all of our numbers or digits. And you're going to notice that in the rest of the spreadsheet that is already pre-populated for you, all of those are centered within the spreadsheet. So you can come in, highlight the cells that you want to format your cells, and maybe go to alignment. And here we can change the alignment, or we can go back up to our Home tab, and in the text portion, we can align our text, either left justify, right justify, or center our text. So now what we want to do is calculate, given a mass, the density of our cube. And so knowing our volume of our cube here, we have a side length of 2 centimeters, a volume of 8 cubic centimeters. We want to calculate our density. And so remember, density is equal to our mass divided by our volume. So I'm just going to put this over here as a little note for myself so that I can know what my equation is. And here, I'm going to do my actual calculation. So I'm going to start with my formula, so my equals sign. And since density is equal to my mass, I'm going to click in A10. And then that is divided by my volume, which is in B5. So when I hit enter, I get a density of 0.125 based on my mass and my volume of my cube. So the smaller my cube is, the higher my density will go based on this relationship of density equals mass over volume. So if this was 2, and my length now becomes 1.26, my density now becomes 0.5 instead of 1.25. I'm going to take this back to 8 for our example here. And the nice thing about formulas is once you've got one formula in, you can copy down and fill in the whole rest of your table very quickly. So you're going to notice as I kind of hover over cell B10, I get this thick plus sign when I want to select different cells. But if I come down to this very low right corner, my plus sign goes to a very small black plus sign. And when I left click and drag, once that plus sign is there, down, I can actually drag my values and fill in my whole table. You can also take that back up so it doesn't populate. Or the other option is, you've got this little button at the end. Once it turns that black, you can double left click and it will populate down as far as these numbers go. You notice that it does not extend beyond the last value in this table. But the other problem we're getting is when we fill in this table, we're getting some errors that occur in our spreadsheet here. So we get a value of 1 here. So given that we have a mass of 2 and a volume of 8, we should be getting 0.5. But we're getting 1 as our density here. And so we're getting that because our cell reference, when we copied this down, actually updated to be A11, which we wanted A11 to happen, but now we have B6 instead of B5. And so what we need to do is we need to use our absolute cell referencing because our volume is a constant that does not change based on our calculations here. So we're going to go back up into the formula in cell B10, and we're going to edit our formula. So here, I'm going to absolute cell address, so add my dollar signs before both my B and my 5 in order to make sure that that stays constant when I do my calculation. And the shortcut here to get your double dollar signs without having to type them in is on a computer or on a PC, you can hit F4 and it will apply your dollar signs. If you are on a tablet or a Surface or another laptop that has the dual tablet functionality, you may have to hit Alt F4 or Control F4 depending on what your hotkeys are. On Mac, you are going to have to do a Command F4, I believe. But every time that you hit F4, it's going to go through. So now if I hit my F4 again on my PC here, you notice that it takes the dollar sign off the B, keeps the dollar sign on the 5. If I hit F4 again, I get only the dollar sign on the B, not on the 5. If I hit it one last time, it goes back to my relative cell addressing instead of that mixed cell addressing. So I'm going to go back to being my absolute cell addressing. So I'm going to hit my F4 one last time so that I get a dollar sign before both my B and my 5. And I'm going to hit enter. So now when I come back up here and I drag this down, I get the appropriate values for my calculations. Again, I'm going to come in here and make these standard to be 3 decimal places. And they're already centered for me, so I don't need to change that. But now my values calculate correctly. So now we're going to scroll down to this very last density chart. And starting in B26, we want to create a formula that we can copy down. So we want to go down first and then across this whole table. So we write one formula with proper cell addressing so that we can copy down and across to very quickly fill in a large table. And you will be doing this pretty frequently within an engineering job of any kind. So here, again, we're working with density as our main value that we are looking for, but now we've got different masses and lengths. So again, we've got to make an assumption here that our length is referring to a length of a side of a cube of material. And then this mass is our cube of material, so a gram per centimeter. And that centimeter needs to be cubed. So we know that our density is equal to our mass, which is going to be A26, divided by our length. Now we're not talking about a volume. So how do we turn a length into a volume? Well, we take our side and we cube this. So I use the B25, our caret symbol, to say that I'm taking this to the 3rd power or cubing it. Or I could have written power and used my power function to say B25 to the 3rd power. So when I hit enter, I get 1. 1 divided by 1 cubed should be 1. I drag that down, and I look at my 4th value is 75. That made quite a big jump compared to it was increasing and decreasing and increasing. And then it decreased a lot in our 5th value, so there must be something wrong with my formula. So again, we need to look back at our formula. I'm actually going to take this out and do it to the 3rd power here. But looking at our masses are all in a single column. They are all in column A. And so our mass column never changes. It is only the row that changes here when we drag our formula down. And if we take this and drag this across, we want to make sure that that A here always stays A, because if we click over here and look at our formula, it's now referencing F26 and G25. Well, the G25 is correct, but our F26 is not correct. That should be A26. So in order to get that to happen, we need to put our $ in front of our A. And then for our lengths always come out of row 25. They never change out of row 25, so we want to hold that 25 constant. So I'm going to hit F4 twice to get my $ to show up in front of my 25. So when I hit enter and drag this down, I now get 1, 2, 3, 4, 5, which is correct for a length of 1. When I drag it across, I get values that look reasonable across the whole thing. And I can even match up, because we know that our volume 8 here had a length of 2. Our last values in this should match up to our values calculated previously in that first density table. And so again, we want to make this very uniform. So I am going to put this to 3 decimal places. Everything else is all centered. And so I've got values here that will help me understand, based on the length of a cube or a side of the cube and a mass, I can determine my density. And say that we can only process products or cubes of material that have a density less than or equal to 1. So we want to highlight those so that we know exactly what our parameters are for processing that. And so we want to take our values here and we want to highlight our whole table. We're going to come up to the top of our spreadsheet to the conditional formatting on the home page. And we're going to use the highlight cells rules. And we're going to do all values less than or equal to 1. And we're going to custom format, so with, and I'm going to come to the scroll box and say custom format, and it's going to pop up a little window here for me. And in this window, I can add borders or fill the cell with certain colors, change the font, maybe make it bold, and we're going to change this to a bright yellow color. And we are going to fill these cells with, say, a dark blue so that they stand out in our table. And so now anything less than 1 is going to be formatted for us. So these are the parameters that work for our processing plant if we need to stick with a density less than 1. So we need to have a mass of 1, a length of 1.2, and so on for each of our different parameters. Okay, I'm going to stop here so that you can get caught up, and we will start the next sheet in the next recording.